As your application grows, you're going to need more screens, so you'll need more views, more controllers, and more navigation. And as you add all that to the application, you add more functionality to it. And that functionality comes along more data. So all the data access that you have in your app is going to go inside your data context. That's where we've been putting it so far. And that service is going to grow. So it's important for that data context to evolve and use good solid patterns so we don't repeat ourselves and we really can maintain our application over time. So in this module, we'll talk about how we can make the service, the data context, grow incrementally and safely. We'll talk about a repository pattern for our data context so we can break things out into functional areas so the data context isn't just one mammoth beast. Instead, it delegates out to different repositories to handle its tasks. But more importantly, we'll talk about when it's appropriate to do this, when it's not, and then how we can accomplish this in a manner that makes sense. And by the end of this module, you'll know when, why, and how to evolve your client-side data patterns using JavaScript. When you're considering getting started with a data repository pattern in JavaScript, it's important to understand why you're doing this and when is the appropriate time to do it. Because you've got this data context and we're about to go down the road of splitting it out into multiple repositories, basically just dividing up the workload. So why would you choose a repository pattern? And don't just take an expert's word for it. Always consider why you're going to go down this kind of a road when you're refactoring your data context out to something like a repository pattern. In our case, it's pretty obvious that the data context is growing and it's going to become more difficult to maintain. And how do you know when it's too big? Well, there's a couple key factors to help you decide when to take care of this. One is the code size. If it's growing large, you'll notice when it becomes a little more cumbersome to deal with. You start repeating code in certain cases. Maybe some of the methods you're just copying and pasting code around. As the data grows, it becomes more difficult to locate the code inside of the data context as well. Once you begin unit testing, it might become more difficult to test, and quite frankly, the most important reason that I look at is comfort. If I don't feel good about how large the data context is getting, or just the code that's in there, because of some of these factors or others, that's when I decide to take action. There is no hard and fast rule of when it gets to 400 lines, that's when you got to do it, or when it becomes this big. But you need to make sure that you feel good about it. So when you're looking at your code and you feel like it's become much larger than the other code base that you have, and it's really difficult to maintain, that might be a great candidate for refactoring, just like we're going to do. Before I begin a refactoring effort, such as what we're about to do with the data context, I like to clearly lay out what my goals are. So let's do that first. First, I'd like to make sure I can reduce what's in the data context and really reuse a lot of the code, because some of it's getting a little more copy and paste. So we're going to divide up the responsibilities for the code in our refactoring effort. And then I also want to make sure all the code's really easy to find. I don't want to overcomplicate it by any means. So as we refactor the code, we'll make sure we stick to these goals. The first step is to make sure we evolve that data context out from being this massive piece of code, which is just going to continue to grow, and then make sure we know what its main responsibility is. And really, it's going to handle saves once we implement that later in this course, and then also expose the repositories themselves. So the data context is going to need a handle on an object, in this case a repositories object, which will be a collection of individual and very specific repositories that we're going to use for data retrieval of specific types. So we might have a repository for sessions or for the people or speakers. And there's always going to be some common data functionality that probably will end up being copy and paste between multiple repositories. Like, for example, a way of just getting all of every particular type. Well, maybe we don't need to copy that code around. It'd be nice if we create some kind of an abstract repository, which will have all that commonly shared repository features. So that'll be the plan in our JavaScript repository pattern. So we're going to take the data context, which is growing, and think of it like a pizza pie, and we're going to slice it up into different pieces, where each one of those pieces will have a specific responsibility. But now let's apply this plan to our actual code. Inside of our data context, we've got a series of methods right now, like these. So how would these look if we split those out into repositories? Well, let's say these are the new repositories that we're going to create. We might have some lookups for things like rooms and tracks. We've got speakers, attendees, and sessions. Where would these methods go? Well, obviously the attendees can go over there under the attendee repository. And then we might rename them to make them a little more applicable. And we'll take the session information, and of course, once the session information is inside of a session repository, we don't need to say get session count. We know what's a session, so we'll just call them get count. And then we'll take the speakers and move those over to their repository, and of course, the lookups. And what we'll end up with is a series of smaller repositories, smaller than the data context was as a whole, and they all just have the functions inside of them for the types that they represent. But what about that commonly used functionality? Well, that's where we might have like an abstract repository, which will have things in there like query failed. Well, if any query fails, I want to just use that one method. I don't want to copy it around. Same things like get all local. If I want to get all the local data that I happen to have in cache, and I can just pass in the type, whether it's a lookup or an attendee or a session. So we can have that common features in its own little common repository. So we're going to delegate the responsibilities out to the different repositories, and this pattern works really well with the combination of Angular and Breeze and JavaScript. To kick things off, we're going to open up the project in Visual Studio from the Before folder for the module in this course, and we're going to scroll down a little bit inside the data context and take a look at the service. These are the different functions that are exposed by our data context that our controller is taking advantage of, like getting attendees and getting session partials and speakers local. All this other information is being pulled in from other controllers and other places in our app. For example, if we go to the sessions controller, we can see here in line 48, we're returning back the results from the data context.getSessionPartials. This method here is actually being called right inside of the data context, and then down here in line 183. And then there's all our data access logic. Now, this isn't overly large at this point. It's 300 lines, and quite frankly, there's a lot of white space too. But as this application grows, this could become really large and, quite frankly, harder to maintain. Right now, we only have about 10 of these methods. What happens when we start adding in other controllers and views, and editing and inserting and deleting? So let's take a look at the code in the after folder for the project, which is basically the evolution of the data context for us using a repository pattern with JavaScript and Angular. So now our data context only has one exposed method. It's actually just the prime method. That's the method we call when our application cranks up so we can go get our lookup information. And the data context also has methods in here to point to repositories for attendees, lookups, sessions, and speakers. Basically, we just split out the functionality for all those different types of objects into their own data access repository. So where are they located? Well, right over here in Solution Explorer, we still have our data context, but now we have these repositories for attendee and lookup and session and speaker. And then we also have an abstract repository. That's going to have some base functionality for us. Things like, getting all the local data, or just getting local entity counts, or handling all the failed queries. And we'll dive into all of these here, but looking back inside the data context, the key here is that the data context is basically just a jumping off point for all of our controllers to get to the data. And the data context decides how it's actually going to get there by talking to these repositories, which handle information about those specific entity types. Now, how you design your repositories is really up to you. I just try to break them out into logical groups. One question you might be asking is, well, is it really bad now that we have 6 different files that we didn't have before, from repositories all the way to repository.speaker? Well, remember that when you load all this in the browser, in production, you're very likely going to bundle and minify all this code into a single JavaScript file. So you're only going to be making one request from the browser to the server to get a JavaScript file anyway. And frankly, the browser doesn't care how these files are stored and organized on the server. It just cares about give me all the JavaScript and I can run it. But because we're humans and we like to be able to find our code when we're editing it or maintaining it, or just designing it from scratch like we're doing here, then we want to make sure we can find that code easily. And by breaking out into different repositories, it's going to help us find it better, and it'll help us with code reuse and eliminate duplication. And the really cool thing about all this is, even though we add all these repositories there, when we call our data context, somebody was going to be calling the getSessionPartials before. So if we go down inside of the session controller and take a look at how that's working now, we'll search for data context, and with the repository pattern, we're going to say data context.session.getPartials, which is slightly different than what we had in the other code. Well, let's take a quick look at the before folders code. Here, back in the sessions controller, we wanted to get session partials. We said data context get session partials. Now in the new code, it's data context.session.getPartials. And the important thing here is that's a minor semantical change, and none of the code or logic changed below it. We're still calling the data context. Now we're saying go to the session repository and get the partials. We didn't have to say get session partials because we're in the session repository. Whereas in the before folder, without the repository pattern, we said data context, you do all the work for us, get session partials. So this is how we call the data context with the repository pattern, And notice the code down here where it gets the data and it sets it, that's not going to change. So let's look over back in the before folder just to prove this. Here's the before project, and it shows us the data context is calling just a different method name. And then here, it's getting the data back. This then call doesn't change at all. And that's what's really cool about this pattern using separation of concerns. The name by which we called the method might have changed just because it made more sense, but what actually goes in and comes out of that method and how it works, as far as the controller is concerned, really didn't change at all. And the net result is we are allowed to refactor the repository and the data context without really affecting the controllers. So now that we've seen an overview of the repository pattern, let's dive in and see how this works. Let's take a closer look at how this refactoring works for us so we can manage this and actually add more code throughout the course for more data access. And to do this, let's start in a repository called repository lookup. Right off the bat, this may look just like any other service that we've created, and it's mostly the same with one big difference. Here we'll see that we're doing an Angular factory to create a service, and we're injecting in this repository abstract. We'll come back to that in just a moment. But this repository lookup service is going to have in here the entity name, the lookups, and then it's also going to get in some shortcut variables. And then we're going to create this function. We're going to call it CTOR. Could be called anything. But this is the big difference here from our services. Instead of returning back and exposing some methods and properties, instead we're going to use a constructor function for our repository. Because we're really only going to create a repository instance on demand. And that's important, so let me say that again. We're going to create a repository instance on demand, so we're going to use a constructor function to do that. In this case, each of the repositories is going to use this pattern, and they're all going to have a service ID, which is the name of the repository, just so we can identify it, the entity name that they're kind of based off of, in this case lookups, and then the manager. That's our Breeze manager, so we can actually access the data. And then below that, we're going to put any specific functions for each repository, like getAll for getAll lookups, or setTheLookups. Now let's flip back into the data context, which is just one of the other services we've created. And remember, we created a factory, exposed the service, and here we don't have a constructor function. We just created this variable called service, which is going to be using the revealing module pattern to expose any methods on here, like prime. So the big difference here in the repositories, we're actually going to create a constructor function right here. We could have created it as a service, but by using it as a constructor function, we're going to be able to access some base functionality from this abstract repository. So to see that in action, let's take a look at the getAll function. Right inside of the repository lookup, we can see down here one slight difference up top here is we've got a self reference, which basically we're going to grab reference to this so we know what object we have. And then our entity query is going to be exactly the same as we had before in our data context, except now we're going to say self.manager and self.queryFailed, and then down here self.log. All the other code in here is the same as we had before. And I've also put a comment in here just for convenience to show you what it was formerly known as. Now you might be wondering, okay, well, where is this query failed and this log method? That's not inside of this repository lookup. In fact, we only have two methods in here, getAll and setLookups. Well, this is where that abstract repository comes into play. The same logging function is going to be used throughout all the different repositories, and quite frankly, we're going to have the same query failed function. Now in this case, I'm using an underscore convention, where anything that's in my abstract repository is going to start with underscore. It doesn't have to, it's just a convention I like to use. So where's that abstract repository? Well, I skipped over a line of code that's really important. That's up here on line 27. What's important about this line of code is it's going to allow this repository lookup, have access to all of the features that abstract repository creates. And it's going to decorate those on the constructor of this object here, the repository lookup. So abstract repository, we're going to extend. It's got an extend method we created, and it's going to pass in the constructor right up here, and we're going to decorate it with functions like query failed and log. And as you might have guessed, all the repositories will have this. So if you go and look inside a repository attendee, you're going to see the same constructor pattern here, and then its specific methods, and of course the abstract repository extend. So both the getAll method and the setLookups are going to have the same exact code they had before. Other than that, they're going to have to reference this because now we're using a constructor object, so we can actually get the properties off our object that we're on. So now we'll say this lookup cache data and this getAll local, and of course here the getAll locals are actually, since they're underscores, they're in the repository abstract. So what did I do to get here? I copied those two methods out of the old data context, put them into this repository lookup. I change them to use this dot, or in this case, self dot, and we expose those as part of the constructor function up here. And one last thing before we look at the abstract repository more closely is notice that I use self here in the getAll, but in the set lookups I didn't use it. Now you don't always have to use self, quite frankly, but for me it's just a safeguard. The reason I do this is if you start having nested functions or closures, you can actually change the meaning of what this is. And because I don't want to have to deal with that, what I do is I create a reference to this right where I know what it is. In this case it's going to be my repository. And then I say, all right, now I've got self, which represents what this was outside of here. I know that's going to be my repository.manager, repository.queryFailed, and also repository.log. I don't have to worry about, no matter how many closures I have, losing the reference to this. Down here I didn't bother because I don't have any closures whatsoever. So now we've taken a look at how the lookups works. Let's go ahead and dive into abstract repository and see how it's decorating the other repositories with its methods. We saw that the repository abstract was being injected inside of repository lookup, and then we extend the lookups repository using abstract repository. So let's see how that actually works. Down inside of repository abstract, we again use a factory to create this, and it doesn't have any dependencies other than common, and that's just so we can get the logger. And then we use a constructor function to put any properties on this particular repository. Now nobody's going to create this directly. It's actually going to be used by all the derived repositories. Each of those repositories, we may want to store data and information, so this is going to have a flag in it called isLoaded to let us know if any of the information in those repositories loaded or not. And they all start off as false. And then on line 17, there's that extend method we called back in repository lookup. Let's go see that again. Repository lookup, we have this abstract repository extend down here in line 27, and that calls into this CTOR extend inside the abstract repository, and it passes in the constructor for the repository it came from. So for example, this could be the lookup repository's constructor. And the pattern we're using here is to set the prototype of the repository, the derived one, in this case the lookup one, using the constructor here. So we're basically decorating the lookups repository with all the features of the abstract repository. And then we want to make sure we put the features back on the lookup repository that it had in the first place. So we then use this line of code to set the prototype constructor back to what it was. So basically this is going to allow us to extend the lookup repository with the features of the abstract shared repository. Okay, so what are those shared features? Well, let's scroll down a little bit. Down here we can see we're putting on the prototype of our constructor several functions. Some of these are things like are items loaded? Do we have getAllLocal? And so on. All these are features we're going to share by the other repositories because these are very generic, like the query failed. And these are the same functions we had in the old data context. We just removed them and put them here, so we could share them around. We also put two convenience functions in for logging and for accessing $Q, just so we don't have to inject that service. Let's take a look at these different functions just to show they're not any different than they were before. Here we've got our items loaded. We have a little different syntax because again, now we have an object, so we can say this is loaded, and we can just return this is loaded. And for getting all local values, we're going to pass in the resource, and then the ordering and the predicate. And the only thing that really changed here again is the this keyword because we have access to the manager. And what's cool about this pattern is the manager object here is not actually defined in the abstract, it's defined in the lookup repository. Notice we don't have a manager defined up top at all, not being passed in either. However, in the repository lookup, we do have a manager right there. But because we're basically sharing it, now we can say this.manager and this abstract repository can use the manager object. The get local entity count, again, same code we had before in the data context, now we just say this.manager. And the get inline count didn't change at all, and then query failed, we didn't have to change that either. So effectively we just copy these functions in from line 37 to 61 from the old data context, put them in here, and then any place we referred to properties that were on the object, we just said this dot. So how is this all going to get cranked up? Well, when somebody creates a repository lookup, it's going to come through here. It's going to extend the constructor function with the abstract features. So we're not only going to get the getAll and the set lookups here, we're also going to get all these other features down here, like are items loaded and query failed. And then it's going to return that constructor back to whoever asked for it, which means that whoever created repository lookup is going to have access to all those methods. And this pattern is used throughout the other repositories, so they also share repository abstract. Each time the repository cranks up, it's going to create its own instance of the abstract repository and use that. We want our data context to be able to access this new set of repositories just by saying data context.attendees or lookups. So to do that, we need a collection of the repositories, basically something to help manage that. So this repository service right here is just a regular service. We're using a factory with Angular to create that. And the purpose of this repository service is to allow us to get the repositories on demand as we need it. We'll pass in the manager, so it knows how to get data. And then the getRepo method does all the work for us. So what he's going to do is we're going to ask for a repository by name. It's going to figure out, okay, which one is it? Then it's going to use the injector service from Angular to go get that repository. This is another form of dependency injection, just we're doing it on the fly. It's more like lazy loading them. So we can say, all right, which one did we need? Let's not create it until we actually need it. So somebody asks for the lookups repository. It's going to say, go find repository.lookup. And then the injector is going to say, go find that for me, please. And then it will create a new instance of it. Notice we're using the new keyword to crank up the constructor for that repository. Repo would then happen to be this repository lookup. So where does the injector service come from? Well, we actually pass that in as a dependency to the repository service. Angular provides it for us. And then we use Angular to go ahead and figure out through the injector service which repository to get. And back in the data context, this is what we're going to call it. The data context is going to have access to the repositories. So we're going to inject that service into the data context. Notice we don't see the other repositories here at all. The data context just gets us one other dependency. So the repositories get passed in, and then in our init method here for the data context, which gets called on line 28, as soon as it gets cranked up, it's going to go off and talk to the repositories and pass in the manager. That's not going to create any repositories yet. It's just going to give the manager object to the repository service so it has it. So back in the data context, then it'll call this define lazy loaded repos method, which is right here, just a local function. And this one here is going to add an ES5 property to the data context for all the repos that we have. So before I explain how this function works, let me show you what it actually creates. It's going to create a property. So basically we can have data context, and we can then just say data context.lookup for the repository, and then call whatever method we might have, like getAll. Or it's going to create a repository when somebody asks for session. So we can say get all the sessions. And how's it going to do that? It's going to get it on the fly. So we're going to go through a list of all the repositories, and that's just a property up top here. We have a local array of the 4 repositories we have. And for each of those, we're going to define a property using ECMAScript 5's feature, define property. And we're going to tell it what's the service. That's the object we're defining the property on. And that's right here. That is the data context. So we're going to define a property on the data context using this name. And that name is going to be the name of the repository, like lookup or session. Then we're going to tell it it's configurable. This means we can change what this property does later. And it's only going to be a getter. We only want to be able to get the value for this repository. So the first time somebody asks for session, it's actually going to come in. It's going to define the property for data context.session. And then it's going to go off and talk to the repository's collection, say, go get the repository session. Which, as we know, because we just looked at it, this collection is going to come in here, say, go get it, inject it. I don't have it yet, so create a new instance of it. So it's going to come back, and we're going to have it. And then we're going to rewrite the property immediately, because we want to keep getting that repository every time. We already have it now. So now we're going to rewrite the property we're actually on, which is kind of neat. So now we're going to say, take the property again on the data context called session, if that happens to be the repository we're getting. And now the value, we're not going to go get it. We just have it already. Just set it to be the repository we just got. Tell it it's not configurable anymore. We're not going to change it anymore. And it's enumerable in case we want to iterate over it. So what we effectively do is for all these different repositories, as they're actually asked for, the first time we come in, we get it, and then we redefine what this property is going to look like by just saying, all right, don't get it anymore. Now we have it. No matter how many repositories you create, all you have to do is just add them to this repository names array, which if you wanted to, you could store that in a config file and you could inject it as well, and it will create all these different properties on the data context for you, representing each repository. So let's follow this through from a controller. We'll go over and find the session controller. And down here, we've got a call for getting the sessions. We'll find the data context. Say data context session get partials. Well, when we call data context.session, what's going to happen? We're going to go into the data context. This method's going to say, all right, what's the get going to do? I want you to go talk to repositories and get the repo called session. And then that's going to go over and say, all right, go get that. Use the injector to get repository.session and then crank it up, instantiate it. And then when you instantiate it, it's actually going to create that repository session and it's going to extend it with repository abstract. It's going to return it back down over to the data context. And immediately before we do anything else, it's going to say, next time, don't go get it and crank it up. I have it. Here's a handle for you. Just use it. And then we're going to say define the property, use that repository as the value, and return it. Then back in our controller, we know we've got data context.session. Subsequent calls don't have to go find it. They don't have to crank it up. We can just access the methods like get partials. So as far as our controllers are concerned, not much has really changed. And it's all because of the way that we're using this to find lazy loaded repos to manage our repository collection. And the only other thing that's inside of the data context is the prime method. And the only thing that really changed in here are the calls to the data access methods, because now we have to talk to repositories for those. So we'll say service.lookup.getAll, and service happens to be the data context local variable, and then service.speaker.getPartials. And then down to line 69, we say service.lookup setLookups. But everything else we have in here is identical to what we had before in the data context for the prime data. And the reason the prime method stayed inside the data context but the others didn't is because prime is really talking to multiple repositories. And when we talk to multiple repositories, we need a place to do that. And the data context can go off and talk to several repositories, get all the data, aggregate it, and then do what it needs to do. And this was the only thing that we needed to do that with so far. Another example of a good method that would stick inside the data context might be a save method, because maybe we want to have a unit of work over our repositories. And we will get to that later in the course. Once you get one repository down, the rest of them kind of fall in line. So we took a look at repository lookup, and notice when I flip over to repository attendee, the top looks eerily similar. So here, it's very similar. We just changed the name to attendee. We're still injecting in model and repository abstract. And then we call it repository attendee, of course, because that's what it is. We added a little bit different stuff up here, like we needed to know an order by and a predicate, because the queries inside needed that, whereas in lookups, we didn't care about those things. And here in the constructor function, we have the service, the identity name, and the manager, just like we did for repository lookups. And then below in repository lookups, remember we exposed our data access functions for getAll and setLookups. We do the same thing inside of attendee. These are the data access specific functions for the repository attendee. Now I didn't define these as new methods. These are actually the same methods that came out of the data context that we had before. So when somebody news up a repository attendee, it's going to get these three methods, it's going to get those properties up here, and it's going to extend the object with everything that's in the abstract repository. So once again, we'll get all those other methods like query failed. So let's take a look down here at getAll. In the getAll, we have the same method we had in the data context. One little difference here again is we've got the this, which we're capturing in self. We know that that's going to represent this repository object. So we say self.ourItemsLoaded and self.$Q. And both of those are methods from the abstract repository. When we scroll down, again, the other changes we made here are self.manager. That's going to reference the object's manager. And then query failed. And then some other methods that came out of the abstract repository called ourItemsLoaded and log. And then finally, the self-manager once again. So this method, while it's a little long because we're doing quite a bit of paging and some other features in there, from line 70 basically all the way up to line 29, all the things that change just happen to be referencing this. And here's the old method which we used to call it by. It used to be the data context get attendees. Now, it wouldn't be that. It'd actually be data context dot attendee dot what? Get all. Just like that. So the other methods in here, like get count, they also had very minor changes. We capture this, and then we just say self dot any place that we need it to. Then inside of here, we use this dot manager and this dot get inline count. We can do that if we know what this is going to represent, but we could also just say self right here. because we know that's going to be the object itself, and that's actually a much safer way of going. But I'm just showing you this option as another way to go. I like to be consistent inside of my function, so if I'm going to use self here, I'm going to use it throughout this function called getCount. In the getFilteredCount, I didn't bother with the self because I didn't have any closures or functions inside of here. So in this case, I just did this.manager. And the full name predicate method didn't have any changes from the old data context. So if you compare the code in the before folder and the after folder, you won't see any differences there other than it's now in the repository attendee instead of the data context. So there's just a few changes inside of the repository attendee. And again, you can see the comments of the names we used to call these by. And then at the very top, we define out what this repository looks like. Now that we've seen lookup and attendee, let's go ahead and take a look at the repository session. Again, we have the factory creating that repository. We inject in repository abstract. And we use the constructor function to define the service, the entity name, and the manager. And then we have the three specific methods down here for getting sessions: getCount, getPartials, and getTrackCounts. This should look very similar to what we did in the other repositories because it is. And one of the differences up top is on line 9. Each repository specifies an entity name, so now we can just say what is that entity name. So when we use that inside of here, we can just set it with a local variable. And this one happens to have an order by because one of the queries dictates that it wants it. So once this constructor function creates these three methods and these properties, it also extends itself with the abstract repository again. And then down here, we can see those three methods. The comments show what they were formerly called as, like data context get session count. Now it's just going to be data context.session.getCount. And then we capture this to a local variable called self. And then we call the methods that are in the abstract repository, like rItemsLoaded and $Q. And then also get local entity count. And we're just going to pass in that case, entity name. This is a great example of why we actually have get local entity count in the abstract repository. Because getting the count of how many entities we have in cache, in local cache from Breeze, should be pretty simple to do. And the query is always going to be the same other than what entity am I looking at. So why not just have that code in the abstract repository, pass in the entity name. So if I go down to the abstract repository, we can see the get local entity count accepts that resource, and then just use a very simple query to find out how many we had. We wouldn't want to copy that code into all the repositories, especially as that grows. And then we can define our entity query, and we can specify that we're using the manager and the inline count. And the manager is a local variable here in the repository session, and then the get inline count is actually in the abstract. getTrackCounts, we'll call this getPartials. It's actually reusing another function right here locally. So let's divert quickly and go look at that one. So getTrackCounts calls getPartials. It's right down here. This one's going to capture this into self. And then once we have that, it's going to go off and run the same code we had in the data context before. Again, they're just replacing any place we called local functions with self dot and then that function. We do the same thing for the manager down here in the entity query and the query failed. And then for the rItemsLoaded and the log. So again, getPartials did not change at all other than now we're saying self dot. So back up in getTrackCounts, we call that partials, just like we did in the old data context with getTrackCounts, and then none of the other logic in here changed. Now let's take a closer look at repository speaker. This one's very similar to repository session. We inject the dependency repository abstract. Our local variables just change a little bit, so now we're referencing speaker. And then the order by will be a local variable that we need inside for the queries, and same with the predicate. The constructor function, again, will have the service ID, which will be repository speaker, the entity name, which will be speaker, and then the manager that we pass in. And that's going to be the manager the data context passes to it. Then we have three methods that are very specific to getting speakers. Get all the local ones, get the top local, which we'll use in the dashboard, and the getPartials. And these are the same three functions we had in the data context in the old version, in the before folder. Then we extend this repository with the abstract. Then down below, here's our three methods. Get all the local speakers in this case. Only thing that changed here again was we have self, so we're referencing that. In the getPartials, we again capture self, and then anytime we reference a method, we just say self.getAllLocal, self.$Q, for example, anything that happens to be in this repository or an object of the abstract repository. And all the logic for this stays exactly the same as what we had in the data context. And finally, the get top local has the same thing. Basically capture this in self, and then we use it. So again, none of the logic changed here. We're just using self, or this in this case. Self's just a local variable name. I could have called it Joe if I'd like to. So what you're seeing is that all the repositories just have a couple of methods that are very specific to speaker or session or attendee. So it becomes really easy to extend these to enhance what speakers or sessions or these others do. But now we don't have to expand one large data context and have hundreds and hundreds of lines of code, because throughout this course we're going to do things like edit, insert, and delete different types of entities. And we might have validation as well. So where are we going to put that logic? Well, we could put it all in one large data context, but that would grow pretty large. And this is one way to refactor your data context out and using a client-side JavaScript repository pattern. In most refactorings, there's a little bit of housekeeping. So we have two real important housekeeping steps that we need to make sure we do. One of those is that now that we've changed the way we're going to call the data access methods, we have to go back to the controllers that called them and update their code. So let's start in attendees. The attendees controller, wherever it called the data context, we'll go ahead and find that. We're going to need to make sure we refactor that code. And I've done that in advance to show you it. And in this case, we had data context.getAttendeeCount is going to be refactored to data context.attendee.getCount, because now we're saying data context, go ahead and get that repository, and that's the method we want to use. So what we need to do is search the entire project for any place that we call data context dot. And then we just need to refactor that to tell it which repository to get those methods from. And then if we updated the method name, like it wouldn't have made sense to say, go ahead to the attendee and get attendee count, because we know it's attendees. So I just called it get count. So any place we have that method, we want to make sure we update it. Here we've got it for get count. Then down below we have it for get filtered count. And then for get all. And please do not forget all of this. But here we're just going to say go ahead and get all the attendees. And we can take a look at the next controller. So going alphabetically, we'll look at the dashboard. Inside of here, again, we'll search for data context. We have him here. We say data context attendee get count, data context session get count, and then data context session get track counts. And then down below, we've got data context speaker and data context speaker for getting top local and get all local. And the dashboard has a few extra calls in here because it's showing more information, albeit more concisely, on one screen. Next, let's go over to the sessions controller. And here we'll search for data context, we inject it, and then we say data context session get partials. And in fact, that's the only call inside of this controller. And likewise, inside of the speakers controller, we only had one data context call. We inject it, and then we say data context speaker get partials. So we need to make sure we refactor just how we called that. None of this logic changed, just here, this one piece to call the get partials. So I said there were two pieces of housekeeping. One was to refactor how we're calling data context, which we just handled handily. The next thing is making sure when you add new JavaScript files, which is what we did in the services for all these repositories, we need to make sure we include them in the app. So down in index.html, since we're just doing development mode, we're not bundling or minifying yet, down at the bottom of the page, we want to make sure we include all those repositories. And the easy way to do that is to just highlight those in Solution Explorer and drag them into your index.html, and this will include all those services. And once we complete the housekeeping, that really completes the refactoring of our repository pattern so we can run the app and view it inside the browser. When you're just getting started, your data context is relatively small, so you may not need a repository to get started with. In fact, I recommend you don't start there. But as your application grows and you have a lot more data needs, then you might want to take a closer look at a repository pattern, because all those methods inside your data context may really explode. And as we examined the before and after code for this module, we saw that before we had a data context with about a dozen methods in it, which was going to expand in this course as we add CRUD features and validation. And then afterwards, we had a series of repositories with just a couple of methods in each of those. And all those methods, instead of being jumbled together, are really applied to whatever repository that they happen to be in. Now, we used a lot of fancy words like repository in here, but really, we're just using separation of concerns to separate out different things. We want the plastic in the left bin, the paper in the right bin. we want to make sure we make it easy to find all these items like sessions, attendees, or lookups. So we started with the data context, which really was just one for all the controllers, but as those controllers expand, we made sure we had a repositories collection, which handled all of our repository access for us for sessions or lookups, and then we had a set of shared features in the abstract repository. And again, back in the controller world, all is well because it just accesses the data context just like it did before. Again, using good separation of concerns. And by using Breeze and Angular and JavaScript, we were able to use this common separation pattern, this repository pattern, to help evolve our application. And this will make it easier to maintain and test. We may not start here, and again, I recommend you don't start with the repository pattern until you see a need for it as your application starts to evolve. And that's when you can start refactoring it. And as this course progresses, you're going to see the value of this repository pattern really show itself. Because our code will be easier to maintain, and as far as the controllers go, it's just as easy to code against it. And when we're ready to go to production, we'll minify and bundle all these files and just send them up to the browser in one shot anyway. So we won't have any extra network trips. And this is a very common and powerful way to refactor your application.